separable equations initial value problem. If we just consider this separable equation and solve, then our solution will be in terms of an arbitrary constant c. That means infinitely many solutions. To find the value of c, that is to find the particular solution, we use this initial condition y at 0 equals 2 and get unique solution. Let's do it. First we consider the ordinary differential equation like before. So let's rewrite this in terms of y in the first place in the left hand side and x in the right hand side. So if we do kind of cross multiplying, then it's 3y squared dy equals ex dx. In fact, this is the differential form, this is in derivative form, this is equivalent differential form, and then we integrate both sides, we get 3y squared dy ex dx. Now antiderivative of 3y squared is just y cubed. You can check derivative of y cubed with respect to y is 3y squared is equal to antiderivative of ex is just ex plus c. Now this is cube, take cube root both sides, then we get y equals cube root of ex plus c. I mean, this is where c is an arbitrary constant, so we have infinitely many solutions. Okay, y has infinitely many values, but using this initial condition we can determine the unique value of c. Okay, now we write using y at 0 equals 2, that means y is 2 when x is 0, so 2 equals cube root of e raised to 0, which is 1, plus c. Now let's solve this for c. So cube root, so cube both sides, so 2 cubed, so cube both sides, we get 2 cube 8 equals 1 plus c, subtract 1, so c equals 7. Now go back here and plug in c and get the solution. Thus y equals, y is a function of x. If you want to specify, you can write y as a function of x, or just y is enough, equals cube root of e to the x plus c. Okay, and if we graph, sorry, plus c is 7, c is 7, and when we graph this solution we get only one curve. Now let's do another example. Dy over dx equals x squared over y, and y at 0 equals -1. So let's separate the variables. So y, this is same as y dy equals x squared dx. Now integrate both sides. So antiderivative of y, which is 1/2 y squared, antiderivative of x squared, which is 1/3 x cubed, plus c. Okay, and we want to solve for y. So 1/2, so multiply both sides by 2. Okay, just multiply through by 2, you get y squared equals 2/3 x cubed plus 2c, and take square root both sides, so y equals square root of 2/3 x cubed plus 2c, and plus and minus. Okay, because when we take square root of y squared, since we don't know about y, this is absolute y, and when we get it up absolute value from the left, plus minus goes to the right. Okay, now we want to use this initial condition to determine the value of c, and at the same time plus minus, because we need to have only one solution. Here we got plus and minus. So using y at 0 equals -1, we get y is -1 when x is 0, So y is -1 equals plus minus when x is 0. So this is 2/3 times 0 cube 0, so whole thing is 0 plus 2c, just 2c. Now to get rid of this is square root, square both sides. Okay, square both sides, then we get -1 is square 1 equals plus minus c square is always positive, square cancel 2c, or divide by 2, c equals 1/2. Thus let's go back here, so we get y equals plus minus square root of 2/3 x cubed plus 2 times c. C is 1/2, or 2c is just 1, so 2 times 1/2 is just 1 plus 1. But this is not the final answer. We were supposed to get only one solution. We have plus and minus. Now using the initial condition again, here is the initial condition, we need to choose the correct sign. When we plug in x equals 0, y should be -1. So plug in x equals 0, this is 0 plus 1, 1, square root of 1 is 1, and we are supposed to get -1, so negative is the right sign. Okay, so using y 0 equals -1 again, so y as a function of x, or just y is enough, that's the negative is the correct sign. 2/3 x cubed plus 1. Okay, that's the final answer. So let me box this final.